So monitoring is like, I told that bank that says we'll wait for a complaint. Monitoring is largely alert based.
Right.
And most alerts, I've done this in a lot of companies, and it's, many people have thousands of alerts. They configure very broad parameters. And so you'll see lots of red and yellow and red and yellow. And,
Right.
and actually, our forest of reds, the actual reds are all invisible, cry wolf kind of story. So many people miss the alert, and then things go badly wrong, and then, then complaint happens. So then somebody reacts, even though they've had full monitoring, fair amount of expensive monitoring. Second thing is monitoring as a culture. Though many come, and this I'm telling you as a generalization, but I've seen this many times over, so I suspect it's a valid generalization. Most companies have monitoring teams that only look at some very narrow things. So you'll see monitoring team says system is green, end customer says system is very bad. Because they say, according to these three things, my system is green. There is no, firstly, monitoring teams and the application development teams and all that never meet each other.
Yes.
It's a very common cultural problem that the monitoring team looks at the alerts, has his own review within its own world, and then sends only a digested report, a PowerPoint, to the rest of the world, to the rest of the company, not to the outside world.
Yeah.
The application team only sees the digested report, which is largely good news. So it is, for instance, if they know an API is failing,
Right.
I mean, if an API is failing, the monitoring team knows, but the application team doesn't know, so it never improves that API.
Correct.
This thing is a very common problem, and I'm surprised at how common a problem it is, because you would have thought it was obvious, but it's not, because the organizations are created in these silos.
Right.
And the silos tend to work within themselves. It is not in their interest or in their structure to go and talk to somebody else.
Right.
So, one of the whole cultural shifts from monitoring to observability. What does observability mean? Who is observing? It is useless to have a security guard observe that robberies are happening in the next house, right? It is the house owner who's worried.
Correct.
The house owner doesn't have any visibility, so how can he observe anything? He has no access to the dashboards. He has no access to the raw data.
Hi, welcome to a new episode of Observability Talk. This episode is quite different. For years, I have had the pleasure of engaging in the ideas around technology and observability with our guest, Sankasan Banerjee. Sankasan, or Shanky as we like to call him, has been an IT leader with a lifetime of experience. He has been the CIO of RBL Bank, the NSE, the IIFL Group. He has also worked extensively in technology consulting with stints in Accenture, Mphasis, and IBM. Over the next few episodes, Shanky and I would look at observability through various lenses. We plan to bring more guests who might contradict us, debate with us. Our objective is to go deeper, and today we would like to explore how organizations can build an observability culture. Where should they start, and how should they go about doing it? We will also discuss practical tips, real life experiences, and many more. Hi Shanky, thank you so much for joining us today. It's a real pleasure talking to you about something which is very close to both of our hearts. One thing which I definitely want you to start with, can you define observability in your own words, and why you believe it is essential for some of these enterprises you have worked with, or the new digital first businesses which are coming up?
Yeah, see, I started with e-commerce a long time ago, and the first wave when India world became famous, so everybody started doing e-commerce. So I in those days we didn't have any concept called observability, but we quickly realized as soon as you do a digital transaction, a lot of things are visible to you. You get a lot more data about the individual bits of the transaction, about where the person clicked and where he hovered and all that. And so, as generally across the world, e-commerce players started tracking this quite obsessively. What happens in the whole thing, in the front end, in the middle end, in the back end. Today, it is a fashion to call it observability. In those days, we used to just think, itna data hai, we have to look at what the users do. And equals had this problem that they couldn't physically see users. So data was therefore a very important criterion to decide what to do, how to go about it, who is doing what, funnel drop off, this, that. Now, when enterprises started adopting web technologies, they actually kind of left this part out. I helped many enterprises over the period of time, and most of my, even my enterprise career in my BFSI world and so on, has been on the web side of things, not on the traditional client server or this, that side of things. So on the website, when we started building, we built the interactivity and the other advantages of web, interconnectivity, easy to get access. But this obsessive ability to view each individual action, we kind of left out of that. Primarily because enterprises were not used to doing that. Enterprises were used to looking at the beginning and the end. So what happens in the middle wasn't really, it was considered known. For instance, banks never thought of funnel drop off as anything useful. Okay, he's going to make a payment, he's going to make a payment. Okay, I mean, if he drops off in the middle and starts again, I don't care. When the digital world started maturing, we realized that people actually did care. Banks did care that a payment was not made here, because if the system failed or the payment failed, he would go somewhere else and make it. So banks would start losing money. And as FinTechs came in, which had much better observability and using this data to do things. See, observability by itself is useless. It's actually using the data to improve your system that really mattered. And so suddenly the older banks, the PSUs of the world or the older established banks, started seeing a drop off in their users, especially the younger users. People would refuse to use them because the newer, better fintechs and banks would use the data to improve their systems. Yeah, and therefore, everybody would have a better experience. Whereas the older banks, I remember working in this big public sector bank, and their idea of observability was, okay, somebody will complain, then I will look at it. But that is not observability. Observability means why do you need to wait for a complaint? You can see that the system is already telling you he's in distress. And digital allows you to get down to an individual person's individual transaction, as opposed to the old world where, there was no real way to see an individual transaction.
Right.
So this whole business of going from, okay, once he complains, then I will take a look at it, to looking at it to see if anybody is in distress, that is really the journey of observability.
Correct. So, because you come with the very old sort of technology sense, right? That from old school, where companies or enterprises had this monolithic services, maybe a couple of servers, and then the number of transactions which are hitting the servers was very small, right? To something which basically we're talking about like a million transactions a day, or maybe a billion transactions a day, sort of thing, right? The whole application also has evolved. Uh, the can you talk about a little bit on your experience of this evolution? You talked about that e-commerce time, right? That it was easy for you, or you basically bake it into the technology, that how people are using the application and so on, right? How this technology has evolved over from maybe something which was fully monolithic to now something which is cloud native microservices or serverless sort of thing.
So, people deride monolithic, but I have a monolithic by itself is not bad. There are many,
Yes.
Even Matrix had, the concept of the whole mainframe somewhere in the middle, right? The movie Matrix. So it's not that monolithic per se is bad. In fact, monolithic architectures where they work are a lot simpler than distributed architectures or microservices
Yes.
architectures.
Yes.
The challenge with monolithic has always been explosive growth, because you have one single big thing. You can't suddenly make it double the size or treble the size, right? But NSC, for instance, was largely a monolithic architecture. It was not a microservices architecture. One, because it did very few things. And secondly, at that volume, to give very high reliability, monolithic is actually easier. So now it is, of course, eventually hitting the limits of monolithic and moving out. But NSC, at least when I was there, was largely monolithic. And this was by design because, simpler architecture. It was not entirely monolithic, not one single mainframe, but it was 6 servers doing a billion transactions a day. So to that extent, and we tried distributing it, and with distributing came so many other complications. What really pushed this towards distributed, towards microservices? So, by the way, microservices is a logical way of looking at things. Just because you have 50 services doesn't mean they sit on 50 servers. It can all sit on one single server.
Yes, yes.
And in fact, it quite often does. So this distributed systems architecture push came along when you started realizing that one, vertical scalability has limits. It becomes very expensive beyond a point. So you can build a supercomputer that does everything, but then a supercomputer is very expensive. On the other hand, if you string together a lot of cheap computers, you can get a lot of stuff done. And therefore, especially if you tackle the downsides. So that's what the cloud is about. The cloud is not about big computers. Whoever is buying a 64 CPU machine in the cloud is basically making Amazon rich. This is how Jeff Bezos funds his space trips. Whoever is buying tiny computers on cloud, stringing them up into a highly resilient network, and therefore using that large compute power collectively, is really making his life easier, because it's exponential growth. The cost of a tiny machine is nearly nothing, and therefore the cost of a lot of tiny machines is also nearly nothing.
Right.
But you have to make sure that you understand how to manage a distributed system, which has its own fairly significant complexities. That scalability push came from e-commerce, because e-commerce was very spiky. They were growing very fast. There is the difference between, let's say, Flipkart's slowest day and largest day is about 1,000-fold. NSE doesn't have that kind of spike. It's very rare that NSE, if it grew 1,000-fold, would seriously have to contend with the limits of vertical scalability.
Correct.
So NSE grows 1,000-fold, but over a period of time, not nearly instantly like e-commerce does. And e-commerce is by nature spiky, because sometimes people will come and shop, and then other times they'll go and sleep. And therefore, and it's not predictable. And therefore, the cloud business or the Netflix kind of thing, you don't know how many people will see a movie. You don't know how many. I built the backend of Hotstar, for instance. Well, I didn't build it. I was just a managing team member. I had very bright people below me who built it. But the idea was, Hotstar would not be able to predict how many people want to see a cricket match. And of course, since I've left, Hotstar has grown crazy. When we were there, we were thinking in terms of hundreds of thousands. Now it's I think, reached 50 million is their last number, the highest number ever.
Yeah, 5 and 6.
So again, that kind of spikiness is very hard to deal with in on-premise setups, in fixed setups. So therefore, it becomes very sensible to have this rental model with thousands of servers. Small servers means smaller increments. If you have very large servers, you can put 50 large servers also together. But then each increment becomes very large. And the other thing is, again, this is where observability matters. When we first did Hotstar, we didn't have all this observability business. We couldn't really figure out what was going on. It was very early days, right? So we just put extra servers lying around. Just in case, things go bad, we'll manually attach the server, manually add capacity. So we had it all ready and configured and all that.
Yeah.
And then, of course, we forgot to switch it off. So the peak happened, World Cup happened. Then after a while, Star TV is telling us, we are getting a much larger bill than we thought we would get. What happened? Then we realized we had taken all these servers extra and put them, and we'd forgotten to switch it off. Because nobody was looking at the usage of the servers, and all that data wasn't really available easily in those days.
Correct.
And so, of course, then we went and said, we have to shut this down. So observability gives you this ability to scale at very micro level. You know when you're about to run out of capacity, and therefore you can quickly add capacity. Otherwise, the value of the ability to add capacity is useless if you don't know when to do it. And you can do it manually, but then you will be very inexact. So if you do it automatically using data that the system is telling you, your user growth is climbing, then you do it at that time instead of 2 hours earlier or at the beginning of the day.
Right.
And similarly, when the system is telling you things are not doing very much, then you degrow. And all these adjustments can be made in real time using fairly simple scripting. No AI actually, just very straightforward. AI helps, of course, in improving things, but even well before AI, we were doing all this using simple scripting, using observability triggers. 80% ho gaya, to add kar lo somewhat more capacity.
So that rules or alerts sort of thing, which can be attached to a script, simple script. कि boss, you bring up new
And
services or
how
boot down.
microservices fits in is, now we have better, if you architecturally constructed using individual independent floating services, then you're able to observe each independent service separately, as opposed to saying CPU is occupied. You can say too many people are logging in, which is a much narrower and much simpler this thing. Earlier, we used to say, we don't know what's running inside. We know that the box itself is taking up a lot of CPU. Today, we say, no, too many people are logging in. So give them more machines. Not that many people are doing shopping cart. So
Right.
you need to give them less resources. So the balancing becomes a lot finer across individual services, as opposed to just a very coarse upsizing of the machine itself.
Very true. So, see, microservices also brought in some sort of uh, code complexity, reduction on the code complexity, where you are reducing your code for a service into a smaller chunk and make sure that the service does only one thing and it does that one thing very well, right?
Right. That's where the
Yeah,
architecture part comes in. Not everybody does microservices this way.
correct, correct.
Yeah.
No, no. So that is any a big challenge actually, where
Yeah.
the service is being called and you do not even know what is this, what is the service being called for.
Yeah.
Even that the workflow says that this service should not come in picture. There are a lot of cases we have seen in customer environment when we show them the service map, right? Say why this service is getting called for fund transfer. This is not supposed to be even called, but somebody has written
And
something
you
and
have
it's
to follow a
happened.
certain amount of discipline to encapsulate the service entirely in its own context, which many don't follow. There is a lot of under implied tight coupling. So
Right.
yeah, it's a difficult job to do a very good quality microservice architecture. It's
Correct.
not a trivial job.
Right. So one of the thing, Shanky, what started happening is when this whole evolution happened, a lot of people started claiming that the earlier monitoring tools, per se like NPM, APM, server monitoring, because now we are talking about Kubernetes, microservices, and so on, may not be applicable directly, right? Because APM requires, because the services are coming up and going down, like you said, right? That service itself may not be there when you are trying to monitor things post some time, right? So they said
No,
that
and it's true. For
APM.
instance, we moved to in Finacle, RBL, when my last stint, we used Finacle, and then we moved to a containerized version of Finacle. Now, Finacle used to come with App Dynamics, but it did not come with container observability. It
Right.
came with server observability.
Correct.
And, it's not that the data is missing. The data is available, but, the models are missing.
Correct.
How to take a look at it, how to visualize it on the screen. That was all built for servers. And so we actually had a pretty hard time initially in figuring out, okay, is this service working or not? Because we can't see that particular container, whether it's working or not. We can see the forest of containers, yes. You have 20 containers at 50% utilization, but you can't really see what is happening within a container, what kind of, if a container fails, you don't see it. You see it only when a server fails.
Right, right, right. So this is where this whole observability thing start coming up in US, right? That they say that a monolithic type of application you can monitor using an APM, while a microservices based application or cloud native application you cannot really use APM directly, because the services are very quickly can come up and go down, and it's very difficult to have an APM agent installed and then monitor them, right? Uh, and that's when people start moving towards observability, where they bring in tracing, logs, and
Yeah.
everything into it, right? Now, one challenge which we are seeing in most of the customer environment, right, that people have been doing monitoring. Now we are basically talking about observability. How have you seen this transition happening from something very reactive to a newer technology which can make you more proactive?
So monitoring is like, I told that bank that says we'll wait for a complaint. Monitoring is largely alert based.
Right.
And most alerts, I've done this in a lot of companies, and it's, many people have thousands of alerts. They configure very broad parameters. And so you'll see lots of red and yellow and red and yellow. And,
Right.
if you have a forest of reds, the actual reds are all invisible, cry wolf kind of story. So many people miss the alert, and then things go badly wrong, and then then complaint happens. So then somebody reacts, even though they've had full monitoring, fair amount of expensive monitoring. Second thing is monitoring as a culture. Though many come, and this I'm telling you as a generalization, but I've seen this many times over, so I suspect it's a valid generalization. Most companies have monitoring teams that only look at some very narrow things. So you'll see monitoring team say system is green, end customer says system is very bad. Because they say, according to these three things, my system is green. There is no, firstly, monitoring teams and the application development teams and all that never meet each other.
Yes.
It's a very common cultural problem that the monitoring team looks at the alerts, has its own review within its own world, and then sends only a digested report, a PowerPoint, to the rest of the world, to the rest of the company, not to the outside world.
Yeah.
The application team only sees the digested report, which is largely good news. So it is, for instance, if they know an API is failing,
Right.
I mean, if an API is failing, the monitoring team knows, but the application team doesn't know. So it never improves that API.
Correct.
This thing is a very common problem. And I'm surprised at how common a problem it is, because you would have thought it was obvious, but it's not, because the organizations are created in these silos.
Right.
The silos tend to work within themselves. It is not in their interest or in their structure to go and talk to somebody else.
Right.
So, one of the whole cultural shifts from monitoring to observability. What does observability mean? Who is observing? It is useless to have a security guard observe that robberies are happening in the next house, right? It is the house owner who's worried.
Correct.
The house owner doesn't have any visibility. So how can he observe anything? He has no access to the dashboards. He has no access to the raw data.
Right.
And so a big part of this cultural shift towards observability, again, the FinTechs do it, or the e-commerce guys do it much better. The e-commerce guys, the sales guy is worried about how many sales are happening. Amazon reputedly measures their turnover as pixels, rupees per pixel.
Correct.
They have that screen. Just like a retail store observes, retail stores are very obsessive about data.
Right.
Physical retail is far more obsessive about data than, let's say, banks are. Physical stores really measure sales per square foot, footfalls per square foot, profits per square foot, and they're obsessive about it. I mean, there's a lot of data that everybody analyzes all the time. So, all these early BI use cases, the analytics use cases all came out of Walmart and retail stores, Target. They contracted the IBMs of the world to produce all these models of data. They have cameras following people around. Thing like that.
They do the tick, 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 tick thing when you're getting into the...
All that is data that is input into actual decision making.
Right.
E-commerce similarly inherited that culture that I want to see everything. Now they see everything is digital, and suddenly they realized all that it's a lot richer than the physical world, because you can see in far more detail what happened.
Right.
So analytics does that, but many companies are not used to this culture of using analytics to see things. Now, of course, this is in the business side. In the application development side, analytics also tells you what to build, what not to build, how to improve. IFL, for instance, we realized 60%, this is a long time ago, of course, 60% of our customer queries were password reset on Mondays. Because SEBI has a very strong password reset rule. Every 15 days, you must reset your password. So people reset it, forget it, come on Monday to office and realize they forgotten their password. So they would call, complain saying password reset. So once we did self-reset, 60% of our calls went away. But again, I feel in those days was a small company, so the teams used to sit next to each other and we would interact a lot. But many other companies, like the call center and the complaints team, don't even sit in the same room or the same building as the application development team, or even the same city sometimes. And they are not structured to cooperate with each other. There is no organizational structure that allows them to interact. So therefore, monitoring happens, not observability.
Right. So one of the things which you mentioned actually have also been created as a theory, that watermelon theory people call it, right? That everything from outside will be green, but as soon as you get in, everything is red, like what you talked about early on, right?
Because on the average, it may well be green. So, again, if you look at any monitoring screen, if you take a time period that is long enough, everything will look green. or if you take a time period that is short enough. Okay? But if you dig into the details, you'll see lots and lots and lots of reds everywhere. It's very rare that an organization, unless it has a good culture of observability and not monitoring, is all green. But actually, it should be. When was the last time your Toyota car failed, even in small things?
No, I think somewhere the way you are talking about the cultural part, right, of this whole observability, I think just correct me if I am wrong in understanding what you are trying to say. That one is that what is happening with their application, and then connect it back to the developers, right, to basically get a view in terms of what is failing, how it is failing, and then they basically be able to push the newer updates and so on, and then again sort of a iterative process. But if you have to talk about culture of observability in any of your previous thing, how do you set it up? I mean, for people to go about
So, in
doing it.
fact, I've been doing a lot of that. Now that I don't do all my compliance meetings and my strategy meetings, I do consulting work for this only. This is my favorite passion topic. How to improve systems, especially digital systems. Why is an Amazon so much more reliable than a RBL bank?
Right.
Or for that matter, my mother's blog is more reliable than, commercial websites that many enterprises produce. So this has been a big passion of mine. You see, and I have realized there's a few steps to this. First is you must, and this is what I do at the beginning of every one of my consulting projects. You must force people to come to the table and observe. Application guys tend to say, or infrastructure guys tend to say, looking at the Dynamics data or unit data is monitoring team's problem. Okay.
Right.
But actually, it's not their problem. Monitoring team is not producing anything. Who is producing? The application guys. So if the application guys don't know what's going wrong, what is the point of that data? It's like if the sales guy don't know what is selling, then what is the point of the data? Okay, some security guard knows what is selling, but that's not useful. So I start putting up these weekly reviews saying you must meet once a week. Firstly, everybody in that whole team, that all the 5 or 6 verticals that are involved in this application, they must have access to the data, which is surprisingly not common. People tend to restrict access because, there's no security implication here. It's all read-only data, nothing. But it's just people are, they're used to siloing data. So the first thing you do is it'll take you, an average organization 2-3 months to get all these permissions in place for everybody to be able to see the data. And observability data is entirely passive. It is about history. So there's no security implication.
Correct.
In the sense you can't fool around, you can't make a mistake and alter the data or something. Nothing like that, right? So it's usually pretty easy to get the exemption, but it takes some time. So that is one, to create that layer of permissions that all the stakeholders, therefore, are able to see the same data. Second is once a week, 15 minutes. I need people to see the data, not the presentation, not the spreadsheet. I want people to see the actual screen. So you can drill down and see red way kitna red hai, which is again surprisingly less common. One of the meetings I went to, senior vice president, so I asked him, raw data dikhao. Actual screen kidhar hai, App Dynamics ka ya kisi ka, I don't remember which one.
Okay.
He said, yeah, senior vice president said, junior vice president ko bolo. Junior said somebody else ko bolo. It turns out some guy in Bangalore has access. Nobody in the whole room of some 8-12 people have access. Because, they think of it as a monitoring problem. So it's like, if I attach a heart monitor to myself, I am the patient, but only whoever I bought the monitor from is seeing the data. So once a week, 15 minutes, you need to see the data and use that data to arrive at decisions. Eventually, you must get to all green. There is no excuse for an application that is not all green. Okay? It's just poor quality if it is not green. So even if there are small errors, remove it. Take your time removing it. You don't have to drop everything and remove it. But you should not have it. Why should you have any error in your system? And, never know. Actually, small errors are the one that snowball. When growth happens or multiplication happens, it is the small errors that blow up in your face. Things that you thought was no big deal. And so therefore, eventually you must get to an all-green setup. And that is the first step on observability. The people who are going to make the change need to observe the data. So that is just the error part. But also, you can use the data to improve things.
Right.
If some feature is not being used, either run a campaign or drop the feature.
Right.
Thing like that. So
as yes,
rather
part
than you
this,
put square inch kind of thing, you need to start thinking of actual business outcomes to all your decisions. What does the data tell you?
right, 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 right.
And again, I
That
didn't
one,
come to the banking world I came from e-commerce. I didn't come from banking. So when I first came to RBL was my first banking CIO job. I used to say, app to bana hai. Tell me how many people click it. And they would say, no, we don't know.
right. That the data itself basically was not there. So that is another thing which I think this exercise would do, right? That once you are in a room, everybody is there, people may ask, okay, can I see this data? Right? Maybe it is a failure. Can I see failure response with what all response code it failed with? The transactions are
Yeah.
failing with. It's a simple question,
And go
but I
down to
think
which line, what failed, which line, which API failed, all that. So initially, they start doing that in the meeting. But eventually, it starts becoming a culture because they can now see the data even outside the meeting, right? They can see it 24/7. So they start doing this outside the meeting. And once the errors go away, they start using the data to say, okay, now this feature, why is it not being used? Is it a useless feature or is it a feature that's useful, but people can't figure it out?
right,
We once realized that we built this e-commerce site. We made it look like Amazon. It was, quite successful in its own time. And we had this problem that nobody would go beyond the first few, whatever is shown on the first page would sell very well, but nobody would go much beyond that. So we started seeing what the data was. So eventually we started seeing hover data using Hotjar was even still around. It's a famous tool. It tells you where people are positioning the mouse pointer. And we realized, we had this tree with plus signs, the standard Microsoft Windows kind of tree. And nobody was actually hovering around the plus signs. So we started thinking, why not? I mean, it should be obvious that there is an expansion. And then we went and asked people. They said, no, we thought the plus sign was decorative.
okay,
So, but the data told us that is the question we should ask. Without the data, we would never have asked this question.
correct.
So that kind of thing is what happens eventually. When the error problems start going away, then they start thinking, okay, now the error is not there, but I'm still looking at the data. What else can I see?
Right.
Then it becomes true observability, where, as I said, I spend a lot of time in retail and e-commerce, where people genuinely obsess about data. They like go and look at category data. Did he just move it or did he put it in his cart? Did he put it in his cart? Did he put it back into the shelf? What did he do? Right. So that's not about errors anymore. That's about starting to use that data to improve your product, to maximize your product.
Correct. That's also become like a sort of user experience, what user is able to do,
Yeah.
and how fast you are able to give those responses, and then without failures.
Yeah.
So that
Nowadays,
better user
there are tools. AI has become very good. So there are tools that tell you furious users, as in they have not complained, but they've actually been pretty upset, or irritated users, or merely unappreciative users. They can tell you this, that these users seem to be very furious. So you go and examine what they did and why are they frustrated users, not furious, frustrated users.
Okay.
So go and figure out why they are frustrated.
Right.
And so that really helps you improve the experience, because you start obviously by removing frustrated users. You don't start with mildly unhappy users.
Right. And as part of these meetings, which you basically ask everybody to come, do you also sort of review if people basically have configured the right alerts, thresholds are right? Is it too much of alerts coming in? Is the right alerts getting generated? And sort of discussion around that?
Yeah, so three major discussions happen. One is, once you start seeing the red alert, people will say, oh, to aata hi hai, we just ignore it. So the rule is, if you are just going to ignore it, it is not an alert. If it is a red alert, it means it's a red alert. It means you're supposed to, rush and fix things. If you're not planning to rush and fix things, why are you classifying it as a red alert? So that is the big thing that happens. Second is, one group will say, no, I keep facing issues. And the other group will say, but dekho, kuch alert hi nahi hai, sab kuch green hai. So then something is misconfigured. You have not observed a variable that you should have that would have seen the error.
Correct.
So this is all in the failure part. This is what happens in the first few 6 months or so. People focus on this failure to improve the monitoring itself.
Right.
Should you monitor, for instance, this variable instead of that?
Correct. Correct.
And how much weight should you give that variable? Is it critical to your business or is it just okay, okay? And people eventually start thinking in financial terms, especially if you're on the cloud. All this has you can directly tie it to a cost. So, if like banks, transaction fails in a bank, we can actually figure out what the cost of that is. What is the cost of that failure?
Right.
How much revenue did I lose? How much, did I have to pay a fine or something?
Penalties.
And therefore, I start thinking in terms of not just failures in the abstract, but failures in the impact to business. So if there is a failure that has no impact to business, I'm happy to ignore it and whatever, remove the variable. If a small failure has a very high business impact, then I'm happy to increase its weight and look at it better.
Right, right. And when you are having these discussion on the cultural part of it, right? Is there any specific thing which you do on the development side also? Like obviously, one is that the problems which are coming up now that the developers obviously need to fix it. But is there something? Some time back we were discussing or talking about shift left, for example, right? Where we are saying that boss, when you are started developing, think about how do you observe it, or what sort of thing you need to make sure that it is more observable, right? So are you seeing some of these cultural aspects coming
In
into?
fact, finally, it is the developers that have to observe. Anybody else observing, in the infrastructure guy or the monitoring team observing, is not really useful. I mean, they can do temporary fixes. Okay, like emergency room, theek hai, I'll give you a shock and start your heart. But finally, I need a proper medical care, which means developers have to improve the system. So the observability journey really ends with developers observing and therefore using that observation to continue to improve their systems. Either fix an issue is only when the errors are large. But when they start seeing it again and again, they actually start thinking, this is how the system behaves. System behaves, this is how the usage of the system is, as opposed to the design of the system. And that is how. So if you think of car design, for instance, it's heavily dependent on how people use a car. The original cars were very uncomfortable because they were designed by people who thought cars would behave like this. But as they started getting usage information, they started realizing many of these things can be put in, cars can be made much better. So car engine technology doesn't progress that quickly. But cars have become a lot nicer since, the 1970s.
Right, right, right. Okay.
So similarly, the journey must end with application developers. As in, the application developers must start observing the system to say, this is how I use it, therefore I'll build it like this.
Right, right.
And two or three things are key to this. One is build less. Most people overbuild. So observability tells you whether it's useful to build that or not.
Yeah.
So you should not, for instance, like I make 50 API calls to figure out everything about my customer and then do this and that. It turns out nobody goes to those branches which require those 20 API calls. So then why have 20 API calls and that branch at all? That observability will tell you, okay, nobody goes to that branch. It is not useful. It is not generating any revenue. And therefore, I start forcing application guys to model what the cost of each transaction is.
Right. And Anki, when this developers looking at the shift left part or embedded observability part and so on, right? One of the things which you and me both had discussed earlier also about the logs part, right? While we do get how people are using the app, where they are clicking, what sort of drop-offs are happening, how many transactions are coming in, how many are becoming successful and all. But these are still machinic data, right? But logs is something which we had discussed long time back also, that it provides a lot of contextual data, like what this transaction is about, what is really happening within the application. Can you talk about a little bit about what your thought process are on that?
Actually, till fairly recently, enterprises worried only about instrumentation in the sense of, I want to see if there is usage data, hardware data, SNMP, network data, where it is, which is all data for the underlying system and not about the transaction itself. The transaction produced transaction logs, which would get stored primarily for forensic purposes. They would not actually be analyzed. So the first I call ops data, the data that is required to operate the machine. The second is business data. The transaction actually is that's what the machine is supposed to do, right? So the logs of a transaction are the data for business.
Right.
But technology plays a big role in making that data visible for business. Or other, like InfoSec, for instance, makes a lot of use. So, again, e-commerce world, we realized web server logs are a gold mine. So there were whole companies that came up to analyze web server. Before Google Analytics, there was another company that Adobe bought, which even as a small e-commerce company, we used to subscribe to at fair expense, because that would give us so much idea of how users behaved, which had nothing to do with failures. In fact, it didn't tell us anything about failures.
Right.
But it would tell us, of course, where things stopped. And then we could go and figure out, acha, this page is not loading, that's why things stopped. But by and large, it would not tell us that something has failed or not failed. It would tell us what the path was. Like this hover data I told you, that is Hotjar.
Right.
You would hover on a particular point, which means either, you can make out hover patterns also, in undecided pattern, unconcerned that the mouse is just there and nothing is happening. And you could do a lot of analytics from that to see if your product is good or not, if your transaction is going through or not. So again, Amazon was the pioneer in this. Amazon said, once you've decided to buy, I will have the lowest friction to getting you to pay.
Correct.
It ends at payment. Okay, na? So they would obsessively observe this funnel. Funnel is all from log data. I mean, all from transaction logs. It has absolutely nothing to do with infrastructure.
Right.
And we would obsessively observe the funnel to see where the drop-off happened, what percentage happened where, and is this normal or exceptional, and so on and so forth. That funnel, in e-commerce, the funnel used to be our life. Now, of course, there's a lot more.
Correct.
But, and then where the people came from, what is your marketing campaign to sales ratio? It's not something you can directly observe. But you have the logs of different times. No, I sent out a marketing campaign this time and this was what purchase logs happened.
Correct.
NSE, for instance, we used to use log data to do fraud analytics, circular trading, what Ketan Parikh has been caught for. Things like that.
Right.
So that is all comes from the transaction logs. They don't come from infrastructure.
Right.
And in the API world, the logs have become quite richer because now each API call has a payload, it has a context, it has all kinds of things. So in the API world, as a transaction zips through multiple APIs, you get a lot of information about what happened.
Right. And the stitching also can be done if you look at, because each of the places you have the transaction ID and whatever information you need.
And this, of course, capital markets is really far ahead. Capital markets has been very, very, advanced at taking transaction logs and using it. So almost all algorithmic traders, especially high-speed traders, rely on transaction logs to decide what to do next. They rely on the timestamps within a transaction, what came back, what is the order book position, all that stuff. Because all that comes back in the transaction, and they use that to figure out how to take the next step and all that in microseconds. So capital markets has always been ahead on this. And similarly, NSE tries to figure out whether you're trying to defraud, front run, this, that, all that in through the logs.
Right. In all your consulting assignments or whatever you have been working with customers on this observability side or health and performance of systems, right? What are we obviously talked about a couple of pitfalls, but what are the most common pitfalls you have seen people are not doing right?
So one is, by far the most common, is the alerts are set wrong. And therefore people just ignore it. So this alert is not really an alert. So that basic problem is in tens of thousands of alerts. It's not like a small problem. Right. Any company, in fact, is one of those low-hanging fruits. I get paid a fair large amount of money to say something very obvious. I'll go to a company and say, "Tumhara alerts galat hai." And invariably it will be. There'll be lots and lots and lots of alerts which are, completely useless in the sense that default mein kar diya hai, like 70% CPU utilization. He's put an alert there saying, so what will you do with that alert? No, we ignore it actually. So, and even in the companies I work with, we've had to spend a lot of time and effort removing those alerts.
Correct.
So that you you get to a clean setup, so that when something is actually an alert, it's like health. You need to worry about, if it's a red alert, then you need to worry about it immediately. You can't say, it's not really red. If it's not really red, you shouldn't be having an alert.
Correct, correct. In fact, I was talking to somebody and they did this exact exercise. I can't remember the company name, but what he was saying is that they did this exercise for 3 months. Anytime an alert came, and if nobody reacted to it next 5 minutes, we will disable that alert.
Correct. And that's how it should be. If it is a red alert and nobody is reacting to it, it's a false alert.
Correct. Correct.
And everybody knows it's a false alert. So, therefore, you can disable it without too much concern. The second biggest thing is this siloed culture, where only the monitoring team sees the raw data, everybody else sees digested data. And the digested data is invariably good news.
Yeah, averaged out and showing more green than the red. And I think there are some political issues also here. Do you think that?
Yes and no. I mean, obviously, the guy who's built the monitoring team, who under whom the monitoring reports, which can be in the hundreds of people,
Right.
he's reluctant to give it up. He feels that if everybody watches the data, what will happen to the monitoring team? And that is actually, there should not be a monitoring team. Just like in application development also, there is this theory that you should have a strong QA team. But if you look at the journey of application development or cars, like Toyota has no QA team. Because if a car is defective at the end of the process, then your process is wrong. It's not the car that's wrong. So Toyota really doesn't have a QA team. It has QA teams at every stage. Like there's this famous thing, that anybody can stop the entire supply chain if one screw is loose. Any worker can. That is the culture. That is not the culture in India. A worker stopping the supply chain, he is probably thinking, not only will I lose my job, my entire family will be thrown out into the streets.
Right, right.
So that culture has to come. That quality is important at every stage. Similarly, this culture of full green has to come. That there should not be any red. If there is a red, I must react to it and remove it as quickly as possible.
Yeah.
And it cannot happen, therefore, at the monitoring team. Increasingly, in fact, AI makes it so that most of this can be automated away. So again, NSE is a good example. We have thousands of alerts a day. But it's almost all automated. Temporarily, it'll become yellow. And then so everybody looks at it. Yellow aaya. And then they know it will go away because there's some automatic monitoring remediation. NSE, of course, is further ahead on this curve and it has spent a lot of money fixing it.
Correct.
Because NSE, one error, it blows out to such a level that the CTO has to lose his salary. So therefore, NSE is think of it. NSE nowadays it does about 15 odd billion transactions a day. So having even 10 errors a year is incredibly tiny. But that's why it has put a lot of time and effort into building these automated fixes. But the same technology is available everywhere. It is very rare. For instance, Amazon doesn't have any monitoring team, doesn't have any, team of specialists sitting around looking at the system and fixing it as it goes along, right? It's almost all automated. If it wasn't, they couldn't manage so many servers.
Yeah.
So the same technology is available internally, but that is the next culture. And that the monitoring team has to give up its existence. And that, politically speaking, can be quite tricky. Because the guy who heads the monitoring team can be potentially quite politically powerful.
Correct. So, just extending this to the other side, right? That we are also, I heard a lot of people talking about no ops, right? Basically, there is no ops team required. In fact, when we were talking to Dilip Asbe of NPCI, this was one of the things which he mentioned to us that, boss, we should look at, there should not be anybody who is gluing to a dashboard or a TV and looking at your keyboards, what is happening in our system. There should not be any ops team at all. It should be you generate an alert, you figure out this is a critical alert, this is the problem, go ahead and fix it, and then things continues. So I am hoping with this, some of these AI, Gen AI.
So no ops is actually a combination of three technologies that exist with some culture shifts. One is no ops is created by the application developer. The developer can create a system that doesn't require operations. But to do that, he needs to auto grow, for instance, is a good example. Now, who should do auto grow? if you ask a typical traditional company, they'll say infrastructure will decide grow, auto grow, or manual grow. But why should that be the case? The application developer can build a system so that it takes advantage of auto grow.
Correct.
Because auto grow is not instant, there's a certain delay. So you can set up the system so that the triggering happens well in time and so on. It's very hard for the infrastructure guy to know all this.
Right.
So again, in the .com of the startup world, there is no infrastructure person at all. Nobody is hired for infrastructure in many of these startups, including the startups that I have run. And so I've started discouraging people from hiring infrastructure guys. RBL, we used to have a lot of stuff, 40% of our stuff on cloud and 60% on-premise. The cloud part had 4 people and all provisioning experts. Everything we had insisted everything be automated.
Right.
The physical part had some 200 people. And there again, there was a lot of automation that started happening because the tools are available. And again, there was political resistance. There was a lot of pushback saying, no, let's not automate, whatever. They'll give you other reasons. They won't say, I'm losing my job. They'll say, no, it's unreliable, it's expensive, it's this, that, unsecure. Yeah. All of which is, what? You can work through it, right? What is unsecure about an automation? You can always make it secure. So eventually, but if you look at established company like the Amazons of the world, they have 10,000 servers to one person because most of it is automated. Almost everything is automated. That one person is only when actual things blow up or catch fire. Then, so many of these things, even car factories, there are many car factories in China that don't have any lights because they're run by robots. So whoever comes into the car factory uses a torch because everything is automated. Tesla is a good example. Everything is automated.
Right.
So there's no ops. And it's automated using, of course, the actual robot is moving, but the fact is visibility is all through software. And the whole point of observability is you must do something with the observation. Otherwise, you're wasting your money.
Correct. So far, a lot of folks that monitoring, people who have come from monitoring side to observability, they are still using observability as a monitoring sort of thing, right?
Improved monitoring in the sense that it's still humans observing.
Yes.
But to take that data and write a script, as I said, NSE all was scripts. It's just simple partial scripts saying this trigger happens, do this.
Correct.
But
right,
that culture is still some distance away.
Right.
That's the no-ops culture.
Correct. So,
and the other challenge with the no-ops culture is a lack of knowledge. And it's moving very fast. So actually, if I were to write partial scripts today, people would laugh at me. At least the better IT guys would laugh at me. Because today, there's much better ways to write automation scripts.
Correct. So, if let's say you have to suggest some IT leader that, okay, they have put up an observability culture and they want to assess it, the maturity of that observability culture, what are the metrics which they should look at? Is it that they should do some sort of a survey or what?
I haven't really thought about it. But of course, this culture, they should probably start by seeing how many alerts they have that nobody responds to. That is an easy measure to get, right? How many alerts are there on a day-to-day basis? Because if there are lots of alerts on a day-to-day basis and their business is not collapsing, then the alerts are useless. If I was, let's say, I was a patient and my heart monitor kept going bap, but I didn't die, then I eventually just ignore my heart monitor.
Correct.
So something like that. So that's a good metric. Second metric is this, they can figure out how many cross-functional conversations happen.
Right.
How frequently does it happen?
Right.
I don't know. I haven't really thought about it.
Okay. But the thing which you talked about early on was starting from looking at the low-hanging fruits like number of alerts generating but nobody taking action. Then whether all different teams like developers, QA.
So simple thing. How many people have access? The more people have access to the observability data, the better your culture is.
Yes.
Because, given that it's passive data and entirely historical, ideally everybody should have access. There should not be any particular restriction because there's no security requirement to having restriction on that.
Not having access. Correct. And moreover, finally, the last thing is that how many people, maybe different groups, whether it is developer or business or QA or SRE or whatever, right? are taking action to improve the overall application of
Hardest to measure.
observability and all.
That may be pretty hard to measure.
Right.
But what percentage of the company has access to observability data might be much easier to measure.
Easier to figure out. Right.
Because metrics, otherwise you'll have to find a good proxy. For instance, how many people took action, you'll have to find a good proxy to it. So how many change management requests specify observability data as the trigger? Something like that.
Correct. In this whole observability part, right, there is another term which I just mentioned, SRE, which keeps coming up in most of the places, right? How does SRE team basically is been using observability data? Because SRE again is a very larger concept. Observability is one part of their work, right?
But so SRE, system reliability engineering, is basically about design of systems that are reliable. Again, I've spent some time on this. Think of, let's say, a door latch. Our original Kundi door latch, the chain with the hook. It may not be particularly fancy, but it is incredibly reliable. It can last 1,000 years without too much change, right? And requires no maintenance. It is very hard to break down a door with that kind of latch. So it works very well. But of course, it has other challenges. It will be heavy. The door is a little loose. This, that. You can do all kinds of improvements to it. But many improvements, or even the sideways latch is pretty reliable. Very hard to fool around with it. But for instance, the friction latch has failure points. Eventually, the rubber wears away, so the latch becomes loose. And so that is what reliability is about. By design, how is a system more reliable than... And there are some few basic, of course, it's a very comprehensive field. But there are a few basic things. One is simplicity. The more simple the system, the fewer the moving parts, the more reliable it is. Second is, the more observable, the more reliable it is. Okay. Opaque systems are always, black boxes are always unreliable.
You don't
very
know
hard
what
to
is
fix it. Yeah. No, and it's very hard for anybody to improve it because, how would you improve it? You don't have the data.
Right.
Then there are a few things like that. So that's where observability plays a key role. You have to design a system based on knowing what happens in real life. Because you can accidentally design a very, very good system. Like somebody designed the wheel without having all this observability data. But the fact is that doesn't happen much in life. You have to design it, then observe what happens with it, design it a bit more, observe what happens with it, design it a bit more. And then over a period of time, you get some really nice, simple, reliable design.
That iteration is very important, right? Getting the feedback. That is what the observability word also came from, that control system theory, right? That what your system's internals are, can you basically get certain signals to figure that out, right? That's how the observability thing also came up. And then it's all about iteration.
Correct. Without observability, it's impossible to iterate.
Yeah.
If you don't know what's happening, then you will theorize and the theory may be completely wrong.
Right. Very interesting, Shanky. Shanky, just one thing I wanted to hear from you. How do you see this whole culture, maturity, observability part being impacted by AI and Gen AI? One part you talked about the automation and other things. But is there any other use cases you see Gen AI actually bringing in here?
So, the main thing is that, actually many of this monitoring activity can easily be replaced by Gen AI. Of course, if you have bad alerts, you'll still get bad outputs. But the monitoring part, what today the human does, can easily be replaced. And Gen AI, you can actually, the main challenge with automation used to be that writing these scripts and testing them and deploying them used to be quite tedious. AI can really accelerate that process. For instance, nowadays you have these AI agents.
Agentic AI, correct.
Agentic AI. Agentic AI is ideal in the ops world. It's very easy to write a very simple workflow and then put the rest in English, and then the agent will interpret the English and do as necessary.
Right.
And similarly, some alerts are not deterministic. So there, an agent can come to the point where it requires human input, get the input in English, and act on that.
Right. Shanky, before I let you go, I have one thing which we generally ask all of our guests. What are the books which really inspired you or continue to inspire you, which you always go back to, or the book which you generally give to people? Do you have any recommendations for
Nowadays, I mean, books, of course, I read a lot of fiction. I don't read non-fiction quite as much. I read non-fiction on blogs, not on books.
Okay.
Blogs and newsletters. So there's Lenny's newsletter, which I read a lot. Then there's Stack Overflow, I keep reading for various things. There are quite a few. So Medium is another massive source of great information and good quality. Then I read. So that, I mean, podcasts, of course, some audio podcasts also are very good sources of information for me.
Right.
And many of and I used to, I mean, nowadays I have done a little less of it in the last few years. I actually go to conferences and look at that partner network. You know, of course, the main conference, let's say an Oracle conference or a Finacle conference. So the Finacle and Oracle and all have roadmap, or, you know, they have big announcements. But their partner network often has much better innovation. And that's how, and their innovation in turn tends to have blogs and all that. That's a large part of my gaining knowledge. Today, books are falling behind. By the time you write a book, it's a bit obsolete. That Bharat are valuable, especially around team structures. In fact, there's one 1970s book, the myth of the man month.
Mythical Man Month.
Mythical Man Month. That's still around. It's a 1970s book. It is still, everybody should read it. Even now, companies are making the same mistakes.
Correct. The other book which I really like was High Output Management by Andy Grove. I mean, he talks about more from the manufacturing world, but amazing book.
Then there was another interesting book.
Yeah.
There's that Phoenix Project. It's told as a fictional tale of a CIO and a CISO and a this and that. And it's quite fun to read. It's worth reading about the politics of different pieces and so on.
Okay. Cool.
I haven't read the Andy Grove book. I must read it.
Yeah, High Output Management. Very nice book. Very, very nice book. It was an Intel thing which they were doing at the time.
Yeah, Intel has driven a lot of the concepts of management today.
Right, correct. Cool. Thank you so much, Shanky, for your time. I really, really appreciate this discussion and a lot of stories from your experience, which I am sure a lot of our viewers will find very interesting and insightful. Thank you so much for your time today.
Thanks.
Hope you found my discussion with Shanky insightful. If you did, please consider sharing it with your colleagues. For more information about ViewNet Systems, please visit us at www.viewNetsystems.com.